Children, today let us continue with the practice at 2.2 Maths 1 Algebra. We were doing by factorization method, and this is the question number 1, 8th bit, children, 8th bit, to solve the quadratic equation by factorization method. The equation is 3x square minus 2 root 6x plus 2 is equal to 0. First of all, we have to see whether it is in the general form of the quadratic equation ax square plus bx plus c is equal to 0. If not, then we have to put it in the form, and then we are going to go to the next step. So because this is already in the general form, so next step is to take the n terms, that is 3 multiplied by 2, and find its product as 6, and the diamond method, the middle term is minus 2 root 6. Then how 6 can be written as, that is, you have to split it up in such a manner that when we add or subtract, we should get minus 2 root 6, and when we multiply, we should get 6. Already we know, children, when 2 root 6's are multiplied, we get 6. When 2 roots are multiplied, we get 2. When 2 root a's are multiplied, we get a, and so on. These are the examples taken. So if we write 6 as root 6 and root 6, root 6 and root 6 multiplied, we will get 6, and root 6 and root 6 added, we will get 2 root 6. Because it is a negative 2 root 6, let us take both negative root 6. So negative root 6 plus negative root 6 gives you negative 2 root 6 when added up. So we can write it as 3x square minus root 6x minus root 6x plus 2 is equal to 0. From first two, let us take common. Now what to take common, that we have to understand first. Here we have to split 3 as well as root 6. How to do that, let us see. 3 can be written as root 3 x square, because root 3 into root 3 gives you 3, minus root 6 can be written as 2 multiplied by 3x. Again root 6 can be written as 2 multiplied by 3x plus 2 can be written as root 2 into root 2, so equal to 0. So this is a rough what to be done. Alright, now from the first two again, let us see. Root 3 into root 3 x square minus root 2 into root 3 x minus root 2 into root 3 x plus the last term as it is. See, children, now we can take root 3, we can take root 3x common. From these two, we can take 1 root 3x common. So what will be left? In the first case, root 3x is left, root 3 into root 3, x into x square minus root 2 is left. In the same manner, in the second case, we have to take minus common, because this we want negative, this we want to make it positive, and we can remove root 2. If we remove root 2, in the first case we are left with root 3x plus root 2. It is not plus, because minus we have taken common, so it will become minus, is equal to 0. So what we are getting is root 3x minus root 2 and root 3x minus root 2 is equal to 0. So either root 3x minus root 2 is equal to 0 or root 3x minus root 2 is equal to 0. So root 3x is equal to root 2, x is equal to root 2 upon root 3, or root 3x is equal to root 2, x is equal to root 2 upon root 3. Children, next question. 2m into m minus 24 is equal to 50. It should be in the manner of ax square plus bx plus c is equal to 0. So we can open the brackets, and before opening the brackets we can take 2 to the other side, children. M into m minus 24 is equal to 50 upon 2. That gives us, open the brackets, m square minus 24m is equal to 25, and bring the right hand side to the left. It becomes negative 25 is equal to 0. Now let us just split it up. The end numbers is minus product of the end terms, that gives you minus 25, and the middle one is minus 24. If you take minus 25 and plus 1, you will get it as, after addition or subtraction, minus 24, and after multiplication minus 25. So that gives us the split as m square minus 25m plus m minus 25 is equal to 0. Take common m minus 25 plus 1 m minus 25 is equal to 0. We are left with m minus 25 and m plus 1, and either m minus 25 is equal to 0 or m plus 1 is equal to 0. So you are left with m is equal to 25 or m is equal to minus 1. So your answer will be the roots of the quadratic equation are 25 and minus 1. Alright, now let us come to the 10th question, given as 25n square is equal to 9. Children, the equation should be in the form of ax square plus bx plus c is equal to 0. So first of all, let us put it in the proper form. 2m square minus 9 is equal to 0. So this is in the form of, if you see, a square minus b square can be written as 5m the whole square minus 3 the square is equal to 0. So the identity of the form a square minus b square gives us a plus b and a minus b. So here a is 5m and b is 3. So in the place of a, 5m, plus 3 in the case of B, and 5m minus 3 is equal to 0. So either 5m plus 3 is equal to 0, or 5m is equal to minus 3, or m is equal to minus 3 upon 5. Similar manner, 5m minus 3 is equal to 0, or 5m is equal to 3, or m is equal to 3 upon 5. Therefore, the roots of the given equation are minus 3 upon 5 and 3 upon 5. Let us see the 11th question. It is also similar manner, given as 7m square is equal to 21m. So let us first put it in the general form of the quadratic equation. Ax square plus bx plus c is equal to 0. So minus 21m is equal to 0. Take 7m common, children. You can take 7m common. So you are left with m minus 3 is equal to 0. So here your answer finishes, children. You can take straight away either 7m is equal to 0 or m is equal to 0, and in the second case m minus 3 is equal to 0 or m is equal to 3. Therefore, the roots of the given equation are 0 and 3. 0 and 3. Let us go for the last question of the exercise, the 12th one, given to us as m square minus 11 is equal to 0. So how to be written this? Let us see. Here again same general form, ax square plus bx plus c is equal to 0, because already it is to the left hand side all the terms. So we will continue with the next step. Here, children, we have to write, it is bit different. 11 can be written as root over 11 the whole square. So we have got it as a square minus b square, that gives us as a plus b and a minus b. So a, this is a, in place of b is root 11. So a plus b and a minus b is equal to 0. So either m plus root 11 is equal to 0 or m is equal to minus root 11, or m minus root 11 is equal to 0. We get as m is equal to root 11. So the answer is the roots of the quadratic equation are minus root 11